Hi everyone, for today's lesson, we are going to practice using corresponding parts of congruent triangles are congruent to prove that corresponding parts of congruent triangles are congruent. So we're going to use CPCTC for our proofs today. Before we get started, please make sure that you have already completed and watched the corresponding parts of congruent triangles are congruent video lesson. In this lesson, we talked about what CPCTC stands for. It represents that if you know that two triangles are congruent, then their matching parts must also be congruent. And we did ourselves a quick example. What you're going to do is what we've always done. You're going to prove triangles are congruent. And then from there, you'll finish the proof by proving that other parts are congruent using the reasoning of CPCTC. So let's go ahead and get started. For this very first proof, there are going to be a total of 4 statements and reasons. So I want you guys to label that 1, 2, 3, 4. So now, let's go ahead and look at the information that's given to us. We are told that segment BD is congruent to segment CD. We're told that angle BDA, so here's BDA, this angle, is congruent to angle CDA. Now, based on this information that's given to us, we have a lot of triangles in this image. But there exists 2 sets of triangles that has information inside of them. And so this is where a really good highlighter will help you. It looks like we are working with triangle BAD and triangle CAD. So I would recommend strongly that you use a highlighter or color to identify those triangles. So now that I'm working with the pink triangles, which I'm going to name them. I'm going to name them triangle BAD and triangle CAD. So far in these pictures, I see a side and an angle, and I need another side. And I see right here the reflexive property of congruence, where I can state that segment AD is going to be congruent to segment AD by the reflexive property of congruence. So it looks like I can prove these triangles are congruent by side, angle, side. And what's really nice about that is now that I can prove that these triangles are congruent by side, angle, side, I can now say that corresponding parts, angle BAD, has to be congruent to angle CAD because we would know that the triangles are congruent. All right, here we go. Starting off with our proof, I have segment BD is congruent to segment CD. I can also say that angle BDA is congruent to angle CDA. And I write that because it is given. And what I have here so far is a side and an angle. And so I always check mark those once I have that information identified. My last side is going to come from the reflexive property of congruence. And that is AD is congruent to AD by the reflexive property of congruence. And there's my last side. So now I can say that triangle BAD is congruent to triangle CAD by side, angle, side. I now am ready to say that the triangles are congruent. And since those triangles are congruent, we have corresponding parts. Angle BAD has to be congruent to angle CAD by the fact that corresponding parts of congruent triangles are congruent. We can now say that these 2 angles are congruent to each other. Let's go ahead and look at example number 2. For example number 2, we are told that angle I'm sorry, we are told that segment AD is congruent to segment BC. So here is AD is congruent to segment BC. So I mark that up. Next, I am told that AD is perpendicular to DC. So AD is perpendicular to DC. So that is this entire angle right here. Then I'm told that BC is perpendicular to DC. So since they're perpendicular, that means that they will form right angles. The last thing that I need, well, this is kind of confusing because it's like, okay, which triangle are we working with? And in reality, we are going to be working with these two triangles, A, D, C, and B, C, D. And they are kind of confusing how they overlap. So what I'm going to recommend that we do is redraw out the pictures. I have A, D, and C, and based on my markings, I'm going to mark up what I currently have. AD has a tick mark, angle D has a 90-degree angle, and my other side, this is B, angle C has a right angle, and here is segment D, or point D. BC has a tick mark as well. So now I need one more piece of information. What do these triangles share? So you're not going to want to work with vertical angles. I know a lot of kids see vertical angles, but we are not focused on that. We are focused on the fact that we have two triangles that overlap each other. What do they share? Well, they share this segment down here. They share DC. And so therefore, I'm going to mark up DC. These two triangles share DC, and that's going to be the reflexive property of congruence. I just have to make a decision. Since angle D has a right angle and angle C has a right angle, I think I'm going to make this DC is congruent to CD by the reflexive property of congruence, and that is because of how they correspond to each other. So now it looks like I have side angle side, side angle side. I'm going to prove these triangles are congruent by side angle side, but I'm going to need a statement. That's going to be that triangle ADC is congruent to triangle BCD, just based on what's given to me. And what I want to prove later is that AC is congruent to BD. So eventually, I want to get to that AC is congruent to BD. And look, those side lengths, they match each other. I'm not going to use it, not until the very end, because I need to prove that triangles are congruent. This proof, has 6 statements. And 6 reasons. Let's write down what's given to us first. I am told that segment AD is congruent to segment BC. That right there is a segment that's congruent, so I'm going to already mark up an S. I'm also told that segment AD is perpendicular to segment DC. And I'm told that segment BC is perpendicular to segment DC, and I write that as because it is given. These two pieces, they're not enough information to already work with the letter A yet. So remember that whenever you're working with perpendicular lines, your next statement needs to be that you have right angles. And angle ADC and angle BCD are right angles. And you have to use all 3 letters because the original picture has overlapping pieces. That means that angle D has more than one angle, and so does angle C. So I'm going to say that angle ADC and angle BCD are right angles. So you have to say that they're right angles before you can say that they're congruent. And what came before was the perpendicular lines. So if you have perpendicular lines, then they form right angles. And if you have right angles, we know that if two angles are right angles, then they are congruent. So angle ADC has to be congruent to angle BCD. And that's because if two angles are right angles, then they are congruent. And now I have an A. Next, we need to talk about our last side, and that's going to come from DC being congruent to CD. That's my last side, and that comes from the reflexive property of congruence. So now that I have side, angle, side all checked off, I can now say that my triangles, triangle ADC, is congruent to triangle BCD. And I write that because of side, angle, side. And now this is the easy part. Now that I've proven the triangles are congruent, I can now say that AC has to be congruent to BD because of corresponding parts of congruent triangles are congruent. All right. Here's our last proof of this lesson. In this problem, we want to prove that opposite sides of a parallelogram are congruent. Working with parallelograms, and I think the last one was proving the diagonals of a rectangle are congruent. This is what we're heading to in a later unit called the quadrilaterals unit. We will be talking about these types of properties. But let's go ahead and talk about these. We have given segment AB is parallel to segment CD. We're told that segment AD is parallel to segment BC or CB, and that is given to us. Now we know that whenever we see parallel lines, we always draw in alternate interior angles. So alternate interior angles are always created with the parallel side. So I'm going to say that angle BDC, so I'm going to name that angle BDC, would have to be congruent to this angle up here, and that's going to be congruent to DBA. These two angles, they are alternate interior angles. My next alternate interior angle comes from ADB and CBD. So I'm going to name them ADB and angle CBD. Now these names that I'm coming up with, you can come up with different names as long as you are consistent with your order and what matches. So now that I have angles, I need a side. I absolutely need a side. Angle, angle, angle is not appropriate. So what I also see here is that they both share a side, and that side length is DB. So I'm going to say that segment DB is congruent to, and just based on matching angles, I'm going to say that we have to flip-flop the letters. So this is going to be BD. And that's our reflexive property of congruence. So looking at this triangle, I would say that you would have to prove this triangle, or these triangles are congruent by angle, side, angle, angle, side, angle. I'm going with angle, side, angle. So now what I need to do is I need to come up with those triangles. I need to give them a name. So I'm going to go with like ADB is going to be congruent to triangle. Well, A matches with C, D matches with B, and B matches with D. So triangle CBD. And once I have those triangles being congruent, the corresponding parts of AB and CD, as well as the corresponding parts of AD and CB, those all have to be congruent to each other. let's go ahead and do this proof. This proof has a total of 5 statements. And 5 reasons. Here we go. We always start with our given. Our given is segment AB is parallel to segment CD, and segment AD is parallel to segment CB. And we write this because it is given. I don't have anything to click off yet or check off because I don't have information about sides and angles quite yet, but I'm about to say that. So now, since we have parallel sides, we can now talk about those alternate interior angles, and we need to state both sets. So I'm going to state that angle BCD or BDC that matches with angle DBA. And I need to state that angle, the other sets of angles, is ADB needs to be congruent to angle CBD. And I have to write down both pairs, and the reason why I have to write down both pairs is because I was given both sets of parallel sides, or both pairs of parallel sides in my given statement. Now, you could, of course, break this apart into multiple statements if you want to, but in this case, based on we added like a double piece of information in the given, we can use that double piece of information in the next statement, because our if-then statement is going to be the same. If you have parallel lines, then alternate interior angles are congruent to each other. Next, we have our last side that we needed to talk about came from the reflexive property of congruence, and that was DB being congruent to BD. And that was the reflexive property of congruence. So in terms of checking things off, in statement 2, I have 2 angles that are congruent. And in statement 3, I have a side length that's congruent. And once I have all 3 pieces of information checked off, I am now ready to say that my triangles are congruent. So triangle ADB needs to be congruent to triangle CBD. And that is because of angle, side, angle. And once we know that triangles are congruent, we're basically done with our proof, because all we need to do now is talk about our side lengths. Side length AB is congruent to side length CD, and segment AD is congruent to segment CB. And we write that because corresponding parts of congruent triangles are congruent. CPCTC. And that is the end of today's lesson. If you have any questions over anything I talked about today, please feel free to email me. Otherwise, I hope you have a wonderful day.